Hi everyone. Today we will discuss the topic free body diagrams. First of all, what is meant by a free body diagram? Free body diagram is a diagram which consists of only forces, that too which are acting on a particular body by removing the supporting elements. Now the point is, by removing the supporting elements, what type of the forces you will get in the free body diagram? Generally, by removing the supporting elements, by eliminating the supporting elements, you will get a normal reaction forces in the free body diagram. Now what is meant by normal reaction force? In one word we can say that normal reaction force is nothing but a contact force. Suppose for example, when two surfaces are in the contact position, they exert a normal force on each other which is in the perpendicular direction to the contacting surfaces. So generally in any body there will be so many types of the supporting elements. So we need to remove that supporting elements and we need to draw the free body diagrams, and that supporting elements will be in the contact position to that particular body. So as those are in the contact position and we need to eliminate that supporting elements, so in that combination you will get the normal reaction forces which are in the perpendicular direction to the contacting surfaces in the free body diagrams. So in the free body diagrams, every force will be in the perpendicular direction to the contacting surfaces. You need to remember this direction. And one more thing, in any body if you find any string, wires or ropes in the free body diagrams, you need to eliminate that strings, and by eliminating that strings, ropes and extra etc, you will get a tensional force, and the tensional force will act always away from the body only. You need to remember these two things. First thing is, every force in the free body diagram will act in the perpendicular direction to the contacting surfaces. Second thing is, wherever you find the string, ropes, wires etc, then by eliminating that type of the supporting elements, you will get a tensional force which will act always away from the body. Now coming to the examples, here you can see the first example, a ball supported in a vertical wall by a string and a smooth wall. So here this is the ball which is supported by a string from B to C, and here this part is nothing but a smooth wall. Here smooth wall is the first support, and from B to C, which is a string, is the second support. So by eliminating these two supports, you will get the two forces in the free body diagram. So in the free body diagram, once again draw the original shape of the ball to draw the free body diagram and to get the reaction forces. Now we all know that weight will always act in the downward direction. So project the weight force in the free body diagram. Now here first support, which is a smooth wall, that wall is acting on the ball in this direction. So in this direction, by eliminating this support, you will get the reaction force Ra, which is projecting towards the positive x-axis. Next, here from B to C is the second support, which is nothing but a string. And we all know that wherever you get the strings, you will get a tensional forces which are acting away from the body. So as this is in the second quadrant, you will get one tensional force which is projecting towards the second quadrant and always which is acting away from the body. So you will get the tensional force in the second quadrant. So these are the three forces for the free body diagram for this diagram. Next, see the second example here. A ball supported by a string BC. Next, and resting against the smooth vertical wall and horizontal floor. So here for this body, for this ball, vertical wall is the first support, horizontal floor is the second support, and BC, which is a string, that is the third support. By eliminating these three supports, you will get the three forces in the free body diagram. So to draw the free body diagram, once again project the ball diagram as it is, and here we all know that weight which will act in the downward direction. So project the weight force which is projecting towards the negative y-axis. Next one, coming to the first support, here vertical wall. Vertical wall is acting on the ball in this direction. So by eliminating this vertical wall, you will get one reaction force Ra, which is projecting towards the positive x-axis. Next, second support is horizontal floor. So horizontal floor is acting on the ball in this direction. So by eliminating this horizontal floor, you will get one reaction force Rb in the upward direction, which is in the perpendicular direction to this wall floor. Next, BC is the third support, which is nothing but a string. So wherever you get the strings, you will get a tensional forces. So here BC is in the second quadrant. So you will get a tensional reaction force which is projecting towards the second quadrant and acting away from the ball. So here RA is the reaction force coming from the vertical wall, RB is the reaction force coming from the horizontal floor, and a T tensional force is coming from the string BC. These are the three forces which are coming from removing the supports from this diagram. So these four forces are the forces in the free body diagram for this diagram. Next, coming to the third example, here one ball is resting in a right angled groove. So this is one part of the groove and this is one more part of the groove, and these two parts of the right angled groove are in the inclination part. So in the free body diagram for this ball, you will get the reaction forces in the inclination part, that is nothing but which acts with some inclination with respect to the x-axis or with respect to the y-axis. Now here two supports are there according to the right angled groove. Here two inclined planes are there. So these two inclined planes will be called as the two supports for this ball. So draw the original shape of the ball to draw the free body diagram once again. And here we know that weight will always act in the downward direction. So draw the vertical force W weight force which is projecting towards the negative y-axis. Now coming to the first support, here this inclined plane is acting on the ball in this direction. So in this direction you will get the RA reaction force and it is projecting towards the first quadrant. So in the first quadrant you will get one reaction force RA by eliminating this inclined plane which is the first support. Next, coming to the second support, here one more inclined plane is there. So this inclined plane is acting on the ball in this direction. In this direction it is projecting towards the second quadrant. So in the second quadrant you will get one reaction force RB by eliminating this inclined plane. So from these two inclined planes, two inclined supports, you will get the two reaction forces RA and RB in the free body diagram for this particular ball body. Next, coming to the fourth example, here two rollers are there. Two identical rollers, P roller and Q roller, and which are supported by an inclined plane. This part is nothing but an inclined plane, and here and a vertical wall. So two rollers P and Q are supported by inclined plane and a vertical wall. Here two rollers are there. So we need to draw the free body diagrams for the P ball separately and for the Q ball separately. Now first of all we will draw the free body diagram for the Q roller. So project the roller shape once again to draw the free body diagram. Now everyone observe the Q roller. See how many supports are there for the Q roller individually. So here vertical wall is the first support and inclined plane is the second support, and when you are drawing the free body diagram for the Q roller, P roller will also act as one of the supports for the Q roller. So P is the third support. So from these three supports you will get the three reaction forces in the free body diagram. So now we will draw the free body diagram reaction forces. Now here coming to the first support. So this vertical wall is acting on the Q roller in this direction. So towards the positive X direction you will get the RC force. Next, here inclined plane is acting on the Q roller in this direction. So in this direction means that reaction force will project towards the second quadrant. So in the second quadrant you will get the RB reaction force. Now coming to the third support, P roller support. P roller is acting on the Q roller in this direction. In this direction means RD reaction force will project towards the third quadrant. So you will get the RD force in the third quadrant. So vertical wall is acting on the Q roller in this direction. So in this direction you will get the RC. Inclined plane acting on the Q roller in this direction. So in the second quadrant you will get the RB reaction force. Next, P roller acting on the Q roller in this direction. So in the third quadrant you will get the reaction force RD. So from the three supports you will get the three reaction forces in the free body diagram, and we all know that weight will always act in the downward direction. So you are getting the four forces in the free body diagram for the Q roller. Now coming to the P roller, we will draw the free body diagram for the P roller again separately. Now observe the P roller. and see how many supports are there for the P roller. Here inclined plane is the one of the supports for the P roller. Next one, Q roller will also act as a one of the supports for the P roller. So here only two supports are there for the P ball. So draw the as it is diagram once again for the free body diagram of the P roller. Now see the first support here. Inclined plane is the first support for the P roller. So this inclined plane is acting on the P ball in this direction. In this direction means you will get one reaction force which is projecting towards the second quadrant. So you will get the RA reaction force in the second quadrant. Next one, here P roller is acting on the Q roller which is acting on the P roller in this direction. So in this direction means RD reaction force will project towards the first quadrant. So in the first quadrant you will get RD reaction force. So from the inclined plane is acting on the P roller in this direction. So in the second quadrant you will get the RA reaction force. Q roller is acting on the P roller in this direction. So in the first quadrant you will get one reaction force RD. So there are two supports for the P roller and a weight which will always act in the downward direction. So there are three forces in the free body diagram for the P roller individually. So these are the free body diagrams for P roller and Q roller for this type of the example.